Assalamualaikum and hi. Today we want to present to you about application of differentiation. Before we present to you about application of differentiation, so I would like to uh, introduce me and my friends. My name is Muhammad Isam Alif bin Abdul Radi. Uh, my student number is 2023476912, and I am from CS 143. And also my friend Muhammad Aziz bin Muhammad from CS 110. So we move to the introduction. So in application of differentiation, there was two subtopic, which is related rates and maximum minimum problems. So today we would like to present to you about related rates. So what is definition of related rates? Related rates and problems involving related rates take advantage of quantities that are related to each other. Related rates help us to determine how fast or slow a certain quantity is changing using the rate of change of speed of the quantity of the second quantity. So next, we jump into the techniques to solve differentiation problem. So there are three techniques. So the first one is derivative of sum and difference. The second is derivative of a product function, which is product rule. And the third one is derivative of a rational function using a quotient rule. So why we are using related rates? So in related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity. So it will make more easily to measure. The procedure is to find an equation that relates the two quantities, and we use the chain rule method or implicit method. So now we go to the problem statement. So for question 1, a spherical balloon is being deflated at the rate of 8 cm cube over second. So find the rate of change of the surface area when the radius is 4 cm. So from the question given, we will bring out the information. So as in the picture, dv over dt equal to negative 8 centimeter cube over second. So we need to find dA over dt, which is rate of change of sphere area when the radius is 4 cm. So to solve this problem, we have such a 5 step to make the problem become easier. So for the first step is we write a formula for area and volume of sphere. So we get that area equal to 4 pi r square. For the volume is 4 over 3 pi r cube. So next, for the next step, we must to identify two things. So the first thing is a spherical balloon is being deflated at the rate of 8 cm cube per second. So our dv over dt equal to negative 8 cm cube per second because it is deflated, not an inflated. So that's why our dv over dt become negative. So the second one is the unknown, which is the question: at what rate is the surface area changing when the radius is 4 cm? So dA over dt equal to what? So step 3, we differentiate the formula, which is the formula of area. We differentiate there, dA over dt. We got it 8 pi r. So for the volume, we differentiate dV over dr equal to 4 pi r square. So we move to the step 4, which is design the value for the rate. So dA over dt equal to dA over dV times dV over dt. Then we get there dA over dr times dr over dV. We bracket both that. Then we time with dV over dt. So you got that dA over dt equal to, we substitute the value that we already differentiate in the step 3, which is bracket 8 pi r times 1 over 4 pi r square, close bracket, times with negative 8. So we got there 64 pi r over 4 pi r square. Then we solve there, so we get negative 16 over r. So now we go to the step 5, or our last step. So we will find the rate of change of the surface area when the radius is 4 cm. So we already got the value of r, which is 4. So we substitute into our dA over dt, which is negative 16 over 4. So we got there negative 4 cm square over second. So that is the answer for question 1.
So we go to second problem statement. Given a function fx equal to 8 minus in bracket x plus 3 cube. A. Find the x-intercept and y-intercept. B. Find the critical point of f. C. Find the interval where f is increasing or decreasing, hence determine the extreme point, if any. D. Find the interval where f is concave up or concave down, hence determine the inflection point of f. E. Sketch the graph of f using the above information. Question A is find x-intercept and y-intercept. Step 1. Find the x-intercept. To find the x-intercept, we set fx to 0. First, subtract 8 from both sides. Second, remove the negative sign by multiplying both sides by negative 1. Third, take the cube root of both sides. Next, subtract 3 from both sides. Last, the x-intercept is at the point negative 1, 0. Step 2. Find the y-intercept. First, to find the y-intercept, substitute x equal to 0 into fx. Second, simplify inside the parentheses. Third, cube 3 and subtract. And last, the y-intercept is at the point 0, negative 90. Next, for question B, find the critical point of f. Step 1. Take the derivative fs and compute to f prime x. Step 2. Solve for f prime x. First, simplify x plus 3 power of 3. Second, subtract 8 by 27. Third, differentiate all of fs after simplify. Next, get value in equation. Next, find critical point from that question and get x equal negative 3. So next, for question C, find the interval where f is increasing or decreasing, hence determine the extreme point, if any. Step 1. Analyze the sign of f prime x. Step 2. Determine the intervals. First, negative infinity, negative 3. Second, negative 3, positive infinity. Step 3. Interpret the results by using test value. We can get sin f prime x, which is negative value, and get conclusion, which is decrease. Step 4. Write the interval decreasing and note extreme point. D. Find the interval where f is concave up or concave down, hence determine the inflection point of f. Step 1. Record the second derivative. Compute that using power rule. Step 2. Analyze f double prime x for concavity. Step 3. Determine the interval. First, negative infinity, negative 3. Second, negative 3, positive infinity. Step 4. Interpret the result by using test value. We can get sin f double prime x, which is positive and negative value, and get conclusion, which is upward and downward. Step 5. Write the interval concave up, negative infinity, negative 3, concave down, negative 3, positive infinity. For find inflection point of x, step 1. Verify inflection point. First, concavity at x equal to negative 3. Step 2. Substitute negative 3 into fx. Step 3. Inflection point is negative 3 8. Question E. Sketch the graph of f using the above information. The graph shows cubic curve shape. Since the leading coefficient of s cube is -1, the graph is flipped vertically compared to a standard cubic graph. The graph is always decreasing. This graph has no symmetry. I have plotted 3 points. X-intercept -1, 0, y-intercept 0, -19, critical point -3, 8, inflection point x equal to -3 is transition from concave down to concave up. So our conclusion is, in summary, for the first problem, I determine the rate of change of the surface area of the spherical balloon by applying calculus principle, specifically the chain rule, and using the given deflection rate and radius. For the second problem, I analyze the function comprehensively. For second problem, I identify the x and y intercept, critical point, and interval of increase and decrease, as well as the extremum point. I also examine the concavity and identify any inflection point. Using this analysis, I was able to provide a clear and structured sketch of the function's graph. Overall, this solution demonstrates a true application of calculus technique to solve real-world and theoretical problems systematically and accurately.